Hi, I'm Nikolay, co-founder and CEO at Karoot, and today we're going to talk about telemetry data and why this is super important for AI-powered root cause analysis. So, a few words about me. I have SRE in background, a former head of infra in pretty big company. Now I'm CEO and co-founder at Karoot. We built open source observability tool, and we aim to help developers troubleshoot efficiently and find the root cause using AI automatically. Check out our GitHub repo, and we already have over 7,000 stars on GitHub. And don't forget, give us a star if you like the product. Uh, Everyone talks about AI these days, and our space is not an exception. Everyone wants AI to help us with root cause analysis, but many attempts to this question like breaks because of lack of right telemetry data. For example, if we here I asked to OpenAI and show it to like standard screenshot of node expert metrics from Prometheus, and under the hood, like my application is performing slowly, and why it's happened. And based on these metrics, it's impossible to give an answer to this question. And but let's start from the very beginning and look at LLMs and their capabilities, current capabilities. LLMs, from my perspective, have like general understanding. Understanding, it's not the right word here because we know how LLMs work, and but in fact, we can ask some basic and general questions about how Postgres works, how MySQL works, how network and any component works. We can even show them some log snippets from our logs, and like it can explain pretty complicated Java stack traces. But LLMs know nothing about your particular system and particular issue. Uh, so we need to provide them with right context. And this context is always limited. And these days we have some limitation. Upper bound is like at 1 million tokens as input data. And we should also take into account that LLMs are not non-deterministic. It means the same input, you will never see the same answer. And now I want to talk about prompt or context or input data. It's like in case of current AIs, is synonymous. You can feed the model with any data you have. If you're talking about telemetry data, it can be logs, traces, profiles, events. And in any format, the modern LLMs can easily take even screenshots as an input, but you just need to think about in terms of tokens. But the trick here and catch here is that those data should contain answers to your questions. In case of root cause analysis, the data should contain some signals highlighting the root cause, because LLMs cannot imagine and get more data than you provide them. If you're talking about telemetry data, the most common telemetry data types these days are logs, traces, metrics, profiles in terms of CPU or memory profiles, and events. Um, and the common misconception I've heard many times is that, okay, I have metrics. I installed Prometheus, and now I have all the metrics I need for troubleshooting. Uh, that's doesn't true because our systems are more complicated and out of the box. You will most likely will have like a fraction of right metrics, and like no matter what do you use for storing logs, if your application is not writing to journal and like errors and silently return HTTP errors, your super efficient log storage will not help. And distributed traces are also super limited in their capabilities to reveal root causes because they usually show that some part of your system performs slower or returns some errors. But why it happened, for example, why your database is performing slower, you cannot understand this on the basic uh, distributed traces. Here is my favorite example from Reddit, where a guy asking about a tool to troubleshoot this like unexpected behavior of his system. And the most popular suggestion here is install Prometheus and Grafana. But out of the box, Prometheus, when you install Prometheus and Grafana, they are like just a platform that allows you to gather any metrics and visualize metric. And when we're asking about why my system behave like that, we need to think about data, not storage. And here is an example. Here is an open telemetry demo. It's open source, a bunch of services that communicate with each other, some load generator that generates some requests to the e-commerce application. And every application here is instrumented with open telemetry. So we have a full set of like instrumentation, distributed traces, and this system has no blind spots, everything covered with OpenTelemetry SDK. And out of the box, OpenTelemetry provides a way how to simulate some failures. For example, we will enable a load generator fluid homepage. Like we need to enable the feature flag, and then the load generator will generate much more requests than usual to service front-end proxy, front-end, and then across all dependency graph. So, and let's take a look on example. Here is a heat map showing latency of our traces generated by OpenTelemetry. And we can see latency anomaly here. And let's try to figure out what's happening right now. We just selected one trace from our like outlier trace, and we see just increased latency across all our services, starting from load generator, front-end proxy, and front-end itself. And nothing, we cannot see nothing special here. In our logs, also nothing interesting. Let's act like an experienced SRE and traverse the dependency graph and check what's happened with our services one by one. And here we can see like our service front-end proxy. We can see increased traffic here up to almost 200 requests per second. We also see latency anomaly here. And for the next service, front end also received more requests than usual. We can see latency anomaly here, and let's continue. Product catalog. Here, we don't see any anomalies, excepting drop in request rate. So we should go back to our service frontend and see in more details what's happened there. We can see that because of increased load, CPU usage of the front-end container also has been increased. But it should not be an issue because we have plenty of available CPU time on our node, and that doesn't look like root cause. And the root cause here, the answer here is that our front end is a Node.js application, and Node.js server has a single threaded event loop. And this event loop uh, handles our increased traffic and consumes the entire CPU core, and that's our bottleneck. So we found them, but initially in traces, we cannot understand this without additional metrics about everything about CPU, about Node.js runtime, and like without this magic, we cannot understand what's happening, and especially what we should do to remediate this. And we fed our LLM with the full set of metrics, and it can easily understand what's happened. Here we have an issue with Node.js event loop, and the actually working fix is we just need to increase the number of replicas of frontend. And I tested everything started perform much more efficiently because we distribute our load to 3 event loops, and each event loop can consume different CPU cores, and that's it. But we need to think like broader and understand what we need to provide to LLM as a context. And my current list is that first of all, we need to explain LLM our topology of our system or service map. It can be done, for example, with distributed tracing data, or we use eBPF-based metrics to build a service map. Also, it would be great if we have service level indicator of like latency or success rate for every service or database, logs, events such as Kubernetes events, or what happened in your cloud account, for example, AWS Cloud Trail events, or also uh, any code changes also would be great to have because the majority of incidents happen because of any changes. Resource metrics such as like CPU, memory, like pressure, memory pressure, and disk performance, node metrics, network metrics, since our applications are most likely distributed applications. Runtime metrics such as GRAM, for example, garbage collection activity, thread pools, and so on. Node.js, Python, global interpreted log. But I hope it will no longer be an issue because the modern version can work even without GIL. Golang and database-specific metrics to look into database internals and understand and detect problems such as log contention, bad queries, and so on. Profiles to understand which code consumed the majority of CPU time. And this set should be extendable with custom metrics, but we need to provide an LLM with like clear explanation about each metrics, meaning, and because LLMs not only need to understand that this is the right metric, for example, and find some correlation, and but to suggest you something valuable, it needs to understand what does this metric mean. There are many ways to gather this telemetry data, from manual instrumentation to eBPF-based instrumentation. At Kahoot, we use like a hybrid approach. We use open telemetry data and a lot of eBPF-based metrics. And this is like my favorite slide because no matter where you store your metrics, the bad choice here is an empty storage because, no data for analysis, no answers. And a few words about how approaches how to work with AI for troubleshooting, for root cause analysis. The first one is like expose your data to an LLM through tools or model context protocol, MCP. But based on our experience, this performs not so good because um, non-deterministic nature of LLMs, you cannot explain which tools should be called or which data LLMs should request for understanding what happens. And also, we use more higher level metrics or aggregations to as an input for LLMs because raw metrics can be noisy. And for example, when we look at latency, a particular container, or when we look at aggregation for latency for the whole application with all instances, it's completely like pretty different signals in terms of noise. And at Kahoot, we use like combination of non-LLM approaches to find relevant data and relevant metrics. And then we use LLMs to summarize them and find the root cause because we can have many findings because in distributed systems, many issues can happen simultaneously. And LLM is pretty good to rank them and find the most important things. Uh, and few notes about benchmarks and how we can measure coverage. Unfortunately, currently we don't have any established RCA benchmarks yet, and we like suggest like vendors or users use OpenTelemetry demo with built-in failure scenarios to as a starting point because we understand that it's not super real world examples, but it's something that we can start with, and then we can go deeper and provide more RPA results for more realistic scenarios. And our customers and users all often ask us about, the coverage, like, and it's super tricky to answer because we can't measure how many of infinite set of possible scenarios we can actually detect and identify the root cause. And we just break the whole question to many questions. Like we can, in majority of cases, we can pinpoint the problematic service even without OpenTelemetry instrumentation, just based on eBPF-based metrics. Then we can detect the majority of like infrastructure level issues, such as issues with Kubernetes, underlying nodes, network, and clouds. Then we can detect the majority of the most common runtime specific scenarios, such as problems with JVM, Node.js, and other. And like we can find that the incident is related to recent changes in code or infrastructure by checking Kubernetes events, cloud events, and code changes. And also, we try to deliver insights into database performance because we believe it's super important. Like the big chunk of possible causes are related to databases. And we're almost done. Final thoughts. LLMs are great at structurizing for your findings, and we can usually use them to provide a short summaries what's happened. But we need to feed them with the right context, because without it, it's just autocomplete on steroids. And like the only one requirement here is that your telemetry data should contain the answer, should contain the data to detect root cause. Uh, Otherwise, it's like trash in, trash out. That's it. Thank you for your attention, and let's connect.